All right, Mr. Aiken's
Algebra students, here we go. First lesson done virtually. Whoa. Get yourself to 823. Section 8.2.3 in the electronic textbook. And this is nice because it reviews what we left off with last week before we were let off by the coronavirus. And what's also nice is you can click on things on the electronic textbook that are nice resources that may not show up here as I'm doing this video, but hopefully as I get done through this, this will make sense. This lesson I'm going to do with multiple videos, and when I get done with 877, I'm going to pause, I'm going to stop, and I'm going to say I want you to do 878 using the tricks I'm about to show you, okay? And when I say that, I mean don't watch the next video until you've actually done the problems. That's how you learn, folks. So please do that as we go. Here's what it says. In the last lesson, you developed a method for finding the X-Intercepts. Remember, the X-Intercepts, they're also called the roots or the zeros of the function. That's when we graph one of these, they're called quadratics. Remember how they have a parabola shape, a funny U shape? Well, when you graph them, the X-intercepts are where they cross the x-axis. So, in the last lesson, you developed a method for finding those for a parabola when you get an equation that's in this form. Again, these are called quadratics. By evaluating for y equals 0. In other words, you're given this, but what they want you to do is put a 0 in place of y. That's what they want you to do. Today you'll be using your graphing calculator in a different form of quadratic equations to find the x-intercepts. But in the first problem, they don't want you to use that graphing calculator. So what we're going to do is we're going to use factoring. We know how to do factoring. We're going to do that. So when I look at this problem, the first thing I notice is that every term is an even number. And remember doing Gcf factoring? Remember when we started with factoring and I had you use this process? And I said, oh, step number 1, we got to do Gcf factoring. We're going to look for something that every term has in common. Well, always do that first. When you're looking at a problem, make that the first thing you do. In here, I see that everything is divisible by 2. So I do what's called factoring out a 2. In other words, if I take 2 out of here, what's left? Well, this is what's left. I divided everything by 2. Another way to look at this is if I distribute a 2, 2 times this is this, 2 times this is that, and 2 times 3 is 6. Everything comes back. All these terms come back if I distribute the 2. I factored out a 2. I did a Gcf factoring. Greatest common factor was a 2. Now, I can just look at what's sitting here and do the box and diamond method with what's here and not worry about the 2. So in other words, I'm going to get the parentheses, remember doing that process, for this. I'm going to focus on this. And I hope you remember that process. That process was put the squared term down in the lower left-hand corner and put the other term on the other end in the upper right-hand corner. And then you go, oh yeah, I got to multiply diagonally. And by the way, this works really nice when you factor that thing out. When you see the GCF, factor that out. If you don't, this gets more complex and you might go sideways on this. So look for the GCF first. We multiply on the diagonal. And so I'm looking for a pair of things that multiply to 3x squared and add up to the middle term, 4x. There aren't a lot of ways to get 3. I always look at the things that multiply first. That's what makes this easier. There's only 1 times 3 and 3 times 1. Those are the only ways I can multiply to get a 3. And as it turns out, 1x and 3x multiply to give me 3x squared and add up to give me 4x. I got the right pair of things. I'm excited. So now I know what has to go in these corners. 1x, 3x. And by the way, I can flip these and this whole factoring thing will still work. So it's not that big a deal if you put 3x up here and 1x down there. Now remember, the game is what's in common. In this column, the 3 is in common. In this column, the x is in common. Going this way, you might say, there ain't nothing in common. But actually, a 1 is in common, and in this one, an x is in common. So now I know what is going in these parentheses. I'm going to put the x plus 3, and I'm going to put the x plus 1. If you decide to put 1 plus x, this all still works out. It's not a problem. So now I have this, what's called fully factored. This is now fully factored. I've pulled out the 2, and now I've got these. And as I look inside the parentheses, there's nothing that these two terms have in common. There's nothing that these two terms have in common. Now, however, I have these little problems. Again, we did this last week before we had to split from each other. What I said was, in the zero product property, this times that equals 0. So that means the only way two things can multiply to give me 0 is if this thing equals 0 or that thing equals 0. And what that means is I got two little baby problems I need to solve, and then I will know what will make this original equation 0. So I just solved these two little baby equations. Whatever the factors are, whatever those things in parentheses are, you're going to set each of those equal to 0 and solve, and then you'll have your answers. These again are the x-intercepts. These again are where the parabola will come down and go back up. Or maybe it's the other way around. I don't know yet. But what I do know is these are the zeros or the x-intercepts or the roots. Those all mean the same thing. These are where the parabola crosses the x-axis. And now I'm done with that. The problem is I got the x-intercepts. I don't know where the vertex is. When we were together last week, I asked a number of the groups in the room, well, where do you think that happens? And they said, well, it must be right in the middle. I'm not going to have a vertex over here or up there. The parabola has to have a vertex that's exactly down the middle between these 2 points. So in other words, for our parabola, I know the vertex happens at -2. So in order to find out exactly where along this dotted line that the vertex happens, I just need to plug in -2 into the equation. I could do it here, and actually it's a little easier. Because remember, this is the factored version of that. So I could do it, I could even do it over here. So what I'm going to do is, I'm going to do it in the original, in case you might be wondering, like, is this legit? Is this okay? So I'm going to put in -2 here. Everywhere I see x, I'm putting in -2. Now they don't want us, they said so right here, jerks. They said they don't want us to use the calculator, so we can do this by hand, but I know I would do this on my calculator. By the way, if you do this on your calculator, especially with negatives, put them in parentheses, because your calculator is dumb, and it'll square a negative number wrong, unless you put it in parentheses. Put the number in, then square it. Okay. -2 squared means -2 times -2, that's 4. 8 times -2 is -16, and then I just bring down the 6 to come with it. 2 times 4 is 8 plus -16 plus 6. And we know from our order of operations, I did the parentheses, I did my multiplication first, and now I'm going to add from left to right. We follow the rules of math. 8 plus -16 is -8, plus 6 is -2. Now I know where that vertex is. It's at -2, -2. So apparently my parabola must come down, stop here, and then go back up. And in fact, I can go ahead and sketch this graph with a whole lot of confidence. It's a sketch. It doesn't have to be perfect. Okay? I'm done. I got my x-intercepts. My vertex was right down the middle. I plug in that x value into the original equation, and I got my answer. By the way, if I put the -2 in here, -2 plus 3 is -1. -2 plus 1, excuse me, wow, sorry. -2 plus 3 is +1. -2 plus 1 is -1. And we're multiplying all of these together, and check it out. 2 times 1 is 2, times -1 is -2. I think you're going to find it easier to put in the x value in the factored version than it will be any other way. Okay, enough about that one. By the way, if you're like, what's he doing? This is going too fast. Pause. Go back. Watch it again. You're going to probably pick up something on this that you didn't see the first time. Well, the next one is nice because they let us use the calculator. Okay, so it says use the zero product property to find the roots or the x-intercepts of this. So here I go. I'm going to go through the process again. I'm going to replace the y value with 0 because that's what a root or a 0 or an x-intercept is. I put the squared term here. I put the other term on the other end here, but notice it's negative. Okay, no big whoop. That's what I'm going to do. So I'm going through this process and I'm trying to find a pair of numbers that multiply to -7x squared. So that's what belongs up here. The middle term always ends up here. And this is where it all goes kaput. Because the numbers that I try to use to get -7 are here. -7 times 1 and -1 times 7 will get me here. Remember, you always look at the numbers to get the multiply part. Don't do the add part. Focus on these. What multiplies to give me this? This does. There's no other way to get -7 through multiplication. So now I look at this and I go, oh, what does this add up to? It adds up to -6. No, I want -3. What does this add up to? Oh, this adds up to +6. No, I want -3. So what do? I mean, there's no other way to multiply to -7, so I'm stuck. It doesn't work. In the first question, they say, what happens? It doesn't work. What does this result tell you about the roots? It tells you a couple things. What does it tell me about the roots? It tells me either there are no roots or they're yucky decimals. That's what it tells me. So, then it says use your graphing calculator, and this is where I'm going to pause for a second. And I want to tell you right now, I don't expect you to own a graphing calculator. So don't go running off to Target and get yourself a graphing calculator. Don't do it. Don't spend $120 if you don't own one now. Don't worry about it. I got a backup plan. And the backup plan is called Desmos. So let me take a hot second right now to point out to you how you can get on Desmos. And you've noticed these things with our textbook. They use Desmos a lot. And I'm going to show you how to get there. And I highly recommend you do everything I'm doing. Again, if you get stuck, just pause and come back. So I'm on a clean page and just start typing in D-E-S-M-O-S. Desmos. D-E-S-M-O-S. And it's beautiful free math, and it is. Graph functions, plot data, evaluate equations, export transformations, and much more, all for free. Okay? So what I would do right now is click on the star. You don't have to type anything in, just click the backspace and click done. Because what it does is it puts this happy little green thing here. And this looks like a graph of something. Like Amazon. I don't type in Amazon here. I know what Amazon looks like. Its logo is clear and it sits right here. Make sure it ends up in your bookmarks bar. Not on the very end. Grab it and slide it over here where it's going to be useful to you in mathematics. Okay? And then you're going to click done. I'm not going to click that right now because I got mine right here. And I can go to the scientific calculator. This is a beautiful thing. I can put in that thing right here. I can type in the equation and I think it'll help me out if I can find the equal sign. Maybe the equal sign is not here. Yeah, they've got the equal sign right here. But what they want us to do is they want us to graph. So I'm going to go to the graphing. And they want me to type in, now here's how I do this. You bring up the little keyboard. They want me to type in x squared minus 3x minus 7. By the way, you could use your normal keyboard to type that in, but there you go. Now, I'm going to make the keyboard go away so I can see more of the graph. And I can zoom out. Watch out when you hit the zoom out, zoom in things. Negative is zoom out. It zooms out. It zooms out like crazy. And to me, that's too big of a jump. You could also pinch your fingers together and apart like you do on your phone. And by the way, there's a phone app. I highly recommend you download the smartphone app, Desmos. It's awesome, it's wonderful. But here's the good news. I can just hover over the coordinate where the x-intercept is, and it'll tell me what that coordinate is. So it's 4.541 there, and here it's negative 1.541, comma 0. It shows them both on the screen there too. It's kind of nice. All I did was type in this part. I did not type in y equals. I just typed this in, and it graphed it. If you want to do an additional graph, you could type that in, and it'll show multiple graphs at once. And there it is. It'll give it a different color. And if you want to turn it off, you just tap that. It's still there, but it's turned off. Turn it back on, tap it again. Right? And it'll show you where the x-intercepts are. It'll give you the vertex as well. It's a lovely little program. Works just, here's the great thing. On your phone, it looks so much like this. So if you're using it on your Chromebook or on your phone, it looks and feels the same way in both places. So I highly recommend you get it. So they wanted me to sketch that graph. Okay, I can sketch that graph. Because of what they shared with me, I can just do a quick sketch on the board, in my notebook. In your case, you're going to be doing it in your notebook. I can sketch a graph real quick. And again, it's here and here. And I love that. It just shows me where these things are. And in fact, here's a nice little trick. Negative 1.541, comma 0. And then the other one is at 4.541, comma 0. And then if I want to get the vertex, negative 1.5, positive 1.5, comma negative 9.25. That's what that looks like on my notebook. And you can simply copy that down, a sketch, into your notebook. Notice I didn't take a bunch of time doing a bunch of tick marks. I do know this though. If I'm using graph paper, it does tend to look a little better than this flat out sketch. The book wanted me to do more than that. It wanted me to answer some questions, so I want to make sure I answer these before I pass on any other problems to you. Now, it also talks about using a table. This has a table feature. I'm not going to go into that right now. I think looking at the graph and looking at the points is plenty enough for this problem. In 878, this is where I'm about to pause the video. In 878, they want you to do these 4 problems. Estimate the x-intercepts of the following parabolas by using the graph and table on your graphing calculator. Just by using the graph on Desmos. Remember what we did. Let me do a quick recap. Because I noticed in some of the videos that there needs to be some Gcf factoring. When we did this, we looked for anything that all the terms have in common, and we factored that out first. Then we did the box and diamond if it worked. Sometimes it doesn't. If it does, I'm expecting that you are going to go ahead and factor, set the factors equal to 0, and solve them, plot them, get the vertex, find the vertex, and sketch a graph. If you can't do this, if this doesn't work out, then you're going to Desmos. Then you're using the online resource that you have available to you, or the phone app, either way. But I mean it right now, don't click the next video until you've done these 4 problems in 878. Okay, you'll see them worked out in the next video.